Okay, let's take a look at the top three things you ought to know about triangles. Now, this is coming from my perspective as a math teacher, teaching math, a lot of different levels for many years, and of course, teaching geometry. But I think these are the three biggest concepts that somebody at a minimum would need to want to know about triangles. And in my opinion, too, I think these might be the three most interesting things. But of course, this is just a matter of opinion. But these are whatever ranking they are, because this is kind of subjective. These are three truly important concepts you want to know about triangles. So we're going to take a look at these one at a time. And before I get started, I'd like to invite you to subscribe to my channel. If you like my teaching style, I do tons of videos on all different type of math subjects and levels. So if you enjoy my videos, hope you become a subscriber, and if you do, make sure you hit that bell notification. I do offer full and complete math courses at my TabletClass Math Academy. I'll leave the description of those courses and links to those courses in the description of this video. But with that being said, let's get into triangles. Okay, the top three things we want to know about triangles. Now, before I start with number one, let's just make sure you know what a triangle is. Okay, so here we have a triangle. It's the basic triangle. Now, we all know what a triangle is by looking at it and saying, hey, look, there's a triangle because it has three sides, and the corners are sharp, etc. So that's great. But in mathematics, a triangle is what we call a polygon, okay? A polygon. And a polygon is constructed of straight sides, okay? And the sides, okay, these sides here, they meet at corners. They're called vertices, okay? Or this would be a vertex, and then these here would have this would be vertices. It's the plural vertex. Okay, so the sides meet up at corners. So that's what a polygon is. So we have all kinds of different polygons. You can have quadrilaterals, etc. Right? So whatever figures you can construct with straight lines that meet at corners is a polygon, more or less. Now, polygons have to have at a minimum three sides. Okay, so a triangle is a three-sided polygon. All right, so that's just the basic definition of a triangle. So forget that, we're good to go. So we're off to a running start. Okay, so what's the first thing that you want to know about a triangle? Well, you absolutely want to know that the sum of the angles of any triangle is 180 degrees. So what does this mean? Well, if you look at this triangle, we have an angle here, an angle there, and an angle here. So let's just make up some numbers. For example, let's say this could be, say, 60 degrees. This would be 40 degrees. So that's 100, right? If the sum has to be 180, this is 100. This would have to be 80 degrees because 60 plus 40 is 100, and then plus another 80 is 180. So no matter what combination, if you add up the three angles in any triangle, you're always going to get 180 degrees. And this is extremely important because you're going to, if you're taking math or geometry, okay, one of the most common things you're going to be tasked to do is to find the angles of a triangle, the unknown angles. So if I say this is 25 degrees, this is 90 degrees, what is x? Okay, well, how would I go about doing that? Well, I would say, okay, well, 90 plus 25 plus x has to be all equal to 180 degrees. Okay, so what's 90 plus 25? We kind of do this math. Okay, this is pretty simple. Matter of fact, this is a good little pop quiz for those of you out there doing math or basic geometry. You should be able to solve this. But to solve this basic equation, we're going to want to add up 90 and 25. So 90 plus 25 is 115, right? 115 degrees plus x equals 180. So to solve for x, or this missing unknown, I'm going to subtract 115 from both sides of the triangle. So x is going to be equal to 180 minus 115. Let me just go ahead and just do this here. And that's 65 degrees, okay? So this angle here is 65 because the sum of the angles of any triangle is always going to be 180 degrees. That's the first big thing that you want to know about triangles. All right, let's move on to the next concept about triangles that you absolutely want to know. And this is the triangle inequality, okay? This is actually a couple different concepts in one. I'm going to really focus in on one particular part of a triangle, of the triangle inequality, and I think you'll hopefully find it pretty interesting. Okay, so let's suppose I gave you three, let's say sticks. And let me draw this a little bit better. Let's say I give you this, I gave you this, and I gave you this. Think of them as anything, plastic sticks that are straight line, something you can construct a possible triangle with, okay, or some sort of other figure, right? So three straight things, and these are the lengths of those things. So my question to you would be, and we're discussing the triangle inequality here, could you make a triangle given these three straight lines at these specific lengths? Could you form a triangle? Now, some of you will be like, oh, of course I could. I would just take this long thing right there. Maybe I'll take this second to the longest one. Maybe it's kind of like that long, right? I'm talking about this middle one. And then this smaller one, I could just do this, right? And you'd say, look, I got my triangle using these three lengths. Wrong, that would be wrong. That's not what I'm talking about. You got like an arrow here because you've still got this little like length hanging off the side. That's not a triangle. That's like an arrow or something, right? A triangle has to be perfectly closed, like so. You follow what I'm saying? So in this case, looking at these three sides, hopefully it's kind of, intuitively speaking, you're like, yeah, I don't think we could form a triangle because the best you can do, maybe to try to close these sides up, would be like, let's say this middle side, maybe we can kind of stretch it out like so and take this other side and hoping it can reach over there, but no, I still can't do it. So probably just looking at these three sides, you're like, nah, I don't think I could make a triangle, a closed triangle, right? An actual triangle with these three lengths. Let's take another look at another example. What if I had this, this, and like this? Well, maybe that's a little bit closer, right? Maybe I could take that longest side, take that other side that's pretty long, maybe do it right there, kind of put it at this angle, and then take that little short one and then connect it this way. And maybe I have a nice little triangle that way that's all closed and perfectly aligned. So the question is, when given what lengths can you construct an actual triangle? Okay, well, there's something that we call the triangle inequality that answers this question. Okay, so you don't have to guess, you don't have to manipulate things around. We can kind of know that in advance. Let me give you an example of an actual triangle and we'll talk about it, okay? So let's look at this triangle. And let me do it a little bit better here. Kind of sketching, but I want to make sure I have enough room for some other things. I'm going to put this little symbol there. We'll talk about this here in a second, okay? So this triangle, 3, 4, 5, this is an actual triangle, okay? These lengths are correct, okay? So this is a real triangle, okay? So, but I'm going to use it to demonstrate this concept of the triangle inequality. So the triangle inequality states the following. You can form or construct a triangle if any two sides of the triangle is longer than the third side. So what does that mean? Okay, so let's take a look at this. Let's pick two sides. Okay, let's pick these two sides. Okay, and we'll say, okay, 4 plus 3, is that longer or greater than the remaining side? Okay, which is 5. Do you see that? So if this is the case with any combination of the sides in a triangle, then those lengths could form an actual triangle. So let's go through it. So I did 4 and 3. Is that greater than 5? Yes, it is, right? 7 is greater than 5. So that worked. Well, how about let's try 3 and 5. Okay, let's see if that's greater than the odd man out, which would be 4, right? So 5 plus 3, is that greater than 4? Well, 5 plus 3 is 8. 8 is greater than 4. That's true. Okay, so this was true. This was true. Now we just have to check one more combination, right? And that would be this, 5 and 4. So 5 plus 4, is that greater than 3? So 5 and 4 is 9. 9 is, in fact, greater than 3. That's true. So this was true for all these various combinations. So in fact, this is an actual triangle, okay? So you can construct a triangle in that manner. So the way this would look would be something like this. Let's take another example. Let's say I got my 3 sides. Let's see if I can make up an example real quick, that one that won't work, okay? But you'll see the concept played out here. So let's say this side is 12, and let's say this potential side would be 6, and let's say this was 4. And so the question would be, given these 3 lengths, okay, could you construct a triangle? So we would just say, okay, let me actually do it this way. Let's put this as 13. Make this a little bit more clear, okay? So I would say, okay, let's see here. First of all, I'll say these two. Is 4 plus 6, okay, let's say I had a triangle. It was like maybe this was 6 or this was 4. We're not sure how we can do it, but we'd have to answer this. Is 4 plus 6 greater than 13? Well, 4 plus 6 is 10. 10 is not greater than 13. That's false, right? 10 is not greater than 13. So because these two here is not greater than 13, okay, you cannot construct a triangle from these lengths. Okay, this is a huge thing to know. Hey, if I give you particular lengths, could you form an actual triangle? Now, it failed here, but it works here, right? So 6 plus 13, let's look at this combination. Is that greater than 4? Well, of course that is, right? 19 is greater than 4. And then we could do another combination, 13 and 4, right? 13 plus 4, is that greater than 6? Well, that's 17. 17, that's okay, that's greater than 6. So this is true, this is true. That's good. However, the 4 plus 6, is that greater than 13? No, it's not, okay? This is false. So because any one combination, all 3 combinations of the lengths have to be true in order for these to represent the actual lengths of a triangle. Okay, it's called the triangle inequality. There's another part of it that's it's certainly important, but I think this is a little more important in terms of big picture concepts to know about triangles. Okay, so hey, can you even form an actual triangle? You know, with the particular lengths, that's something important to know when you're talking about triangles. Okay, let's move on to our last one. It's something really good to know, that triangle inequality. That comes up in a lot of different places and a lot of different tests too, like the SAT or ACT, etc. So something to kind of keep in mind if you haven't heard of it before. All right, let's talk about this last concept, and this is right triangles and trigonometry. Okay, so trigonometry is the study of angles in mathematics. So you'll see things like the sine of theta or tangent of 37 degrees, cosine, arc sine of 17 degrees. I'm just writing some random things down that you might see in trigonometry, some symbols and stuff. And if you look on your calculator, if you have a scientific calculator, or maybe on your cell phone where you can turn your calculator into something scientific, you'll see these symbols, SIN, COS, TAN. There's a ton more. This is an extremely important part of math, trigonometry, okay? And I'm not going to get into trigonometry, but I'm going to focus on something about triangles that you want to know, okay? And that is right triangles. Now, right triangles are extremely important in mathematics, okay? They just come up over and over. And so this would be an example of a right triangle. Now, this little symbol right here indicates that this is a right triangle, but I still haven't told you what a right triangle is. Well, what this means is that this angle here is 90 degrees, okay? So any triangle where one of the angles is 90 degrees is a right triangle, okay? And When you have a right triangle, you know all kinds of things about a particular triangle. You know things such as the Pythagorean theorem, a squared plus b squared equals c squared, which is extremely important in mathematics. But this only applies to right triangles. And you really have the fundamental structure, the beginning, the foundations of trigonometry is based upon right triangles. Okay, now it goes into as you progress with trigonometry and whatnot, you deal with triangles that are not right triangles. But when you start learning this stuff, you you learn about right triangle trigonometry. Okay, so let's just talk about right triangle trigonometry a little bit. So let's suppose here we've been talking about triangles, but we've only looked at the lengths of the triangles. We haven't really talked about the angle of a triangle. Well, what trigonometry allows us to do is if we have a right triangle and I'm missing a length, okay, I'm missing a length of the triangle, so that's an unknown value. So I have two sides of a triangle and an angle, okay, some angle. Let's just make this up. This actually has a specific degree to it. I don't know it offhand, but I'm just going to make up an angle here. Let's say this is 37 degrees. So if I have an angle, okay, one angle of a right triangle and two of the sides, I can find the missing side. This is extremely important because right triangles are the foundation of trigonometry. Okay, so the way this basically works is, let me show you another example that is some more interesting. Let's suppose you had this massive tree in the forest here. Here's a tree, and we want to measure how tall this tree is. Okay, like how tall is the tree? Well, unless you're going to climb up to the top of the tree and drop down a gigantic tape measure to the ground, you're going to have a difficult time measuring that tree. However, what we could do, knowing some trigonometry, let's just suppose this tree, okay, the trunk of it was like a perfectly perpendicular to the ground, meaning that it would form a 90-degree angle. So I could kind of just draw a line out like so and be like, okay, how could I solve for this here? Well, if I can get this angle, let's say this is 37 degrees, and I can get this measurement away from the tree. That's, pretty easy to get. I just kind of measure out from the tree trunk out to where I'm looking. And let's say this is 150 feet. Okay, so let's say at 150 feet, I look up at the top of the tree. I use some sort of instrument, and it forms 37 degrees up to the top of the tree. I can determine, and this is a right triangle, notice here, this is the right triangle would look something like this. Okay, I want to know this amount. I have 37 degrees right here, and this length here is 150. Okay, so what trigonometry allows us to do is with just given this information and the fact that it's a right triangle, I can solve for this length, I can solve for this length, I could do all kinds of stuff. That's the real major impact of trigonometry. It solves really huge problems in mathematics. But the thing about it is it's grounded in the study of right triangles. So when you're talking about triangles, your study of them, the field or this kind of like when you really specially take a deep look at right triangles, okay? Let me just say it that way. You learn a lot about them, a lot of different theories, properties, etc., because they're just particularly that important, okay? And they, again, are the foundation to an even more advanced part of mathematics called trigonometry. So let's just kind of wrap it up right there. So that's my take. Again, this is subjective, but as a math teacher, if I had to say, hey, what are three big things that you want to know about triangles that are both extremely important from a mathematical standpoint and I think interesting, this is what I would give you. Again, the sum of the angles of a triangle, any triangle, is 180 degrees. Triangle inequality lets us know if three lengths, okay, if we take any three combination of lengths, whether we can in fact form an actual triangle from that. And then the idea that right triangles are in fact so important, okay, those right triangles are triangles that have a one angle 90 degree, that they're so important that we know so much about them, and they are the foundation of trigonometry, is something that's definitely you want to know. All right, so let's go and wrap it up. Again, if you like the way I teach, hope you consider subscribing, hit that bell notification. I do tons of videos on various different subjects. And of course, I have formal courses as well. Again, I'll leave links in the description of the video. And hey, if you like the video, hope you consider giving it a thumbs up and leave me feedback. It's the only way I know how I'm doing, and also gives me ideas on future videos that I think that you can benefit from. Or if you have particular questions, if I see enough people asking about a particular topic, I try to make a video about those things as well. But with that being said, I definitely appreciate your time and have a great day.